Okay, so here's another one of those problems where I am, it's a limiting reactant problem. We know that because the question is asking about both reactants. I'm telling you we have 4 grams of silver and 4 grams of sulfur. And this isn't a problem where I say, and the sulfur is in excess. I'm telling you that we have a limited amount of both of those. And I'm asking, what is the mass of the silver sulfide that is produced afterwards? And we're going to do this that new way that we just learned. So I wrote down the steps here so you can follow this one. Right? Step number 1, convert both reactants to moles. So we start with 4.00 grams of silver and 4.00 grams of sulfur. This is a different, you don't really need to know this, but that's a different allotrope of sulfur. That's actually 8 sulfur atoms all bonded together. So the first thing, right, we always convert both to moles, right? 1 mole of S8. This one has a big molar mass, 256.56 grams. And what do I find? I start with 0.03707 moles of silver and 0.01559 moles of S8, right? And you may ask, like, this 4.00 grams, that has 3 significant figures. Why am I writing these, right? Remember, we only really worry about significant figures at the very end. So I'm not rounding, and where I can, I'm using the whole numbers in my calculator. So remember what these are. This is how much of these reactants I have. So this is reactant 1 that I have, and this is reactant 2 that I have. So step 2, right? We're checking to see, is the first reactant the limiting reactant? Is the silver the limiting reactant? So the question I'm asking is, if I used up all of the moles of reactant 1, if I used up all the silver, how much sulfur would I need, right? So we're starting with, right, we said we're going to convert reactant 1 to reactant 2. So how much reactant 1 did I start with? 0.03707 moles of silver. And according to the balanced chemical equation, 1 mole of S8 will require 16 moles of silver. It's a lot of silver. So now when I look at that, I am going to need 0.00231 moles of S8. So remember, I said label this as R2 needed. This is how much sulfur I'm going to need to use up all my silver. And so step 3 is comparing need versus have, right? Compare the moles of reactant 2 that you have from step 1. That was 0.01559. That's the number of moles of S8 that you have to the number of moles of reactant 2 S8 that is needed. That's that number that we just came up with, 0.00231 moles of S8 needed, right? If the number of moles of reactant 2 that you have is greater than the number of moles of reactant 2 needed, then reactant 2 is in excess, right? That means we have more than enough. And if you have more than enough of the second reactant, that means the first reactant is the limiting reactant. And then vice versa, if the number of moles of reactant 2 that you have is less than needed, then reactant 2 is the limiting reactant. So here's sort of the summary, right? If needed is less than have, reactant 1 is the limiting reactant. If needed is bigger than have, then reactant 2 is the limiting reactant. So what was it in this case, right? So we're always comparing reactant 2. We're comparing S8. And this is saying that, remember, I have 0.01559 moles of S8. That's what I have. And in order to use up all my silver, 0.00231 moles of S8 is needed. So which one, right, is needed less than half or is needed greater than half? Well, it looks like in this case, needed is less than half, right? Because what this is saying is that in order to use up all my silver, that's reactant 1, I'm only going to need to use 0.00231 moles of S8, and I have way more than that. 0.015 is more than 0.002. So then reactant 1 is my limiting reactant, right? So write a sentence stating your, write a sentence stating your limiting reactant and the reasoning you use to come to that conclusion. So the first thing we're going to say is that reactant 1, so 4.0 grams of silver, is the limiting reactant. And then, right, think about, this is where the logic is coming in. In order to use up all the silver, I would need to use, right, and this was the needed, right, 0.0023 moles, or we can do this in terms of moles. We don't need to do this in terms of grams. I would need to use 0.0023 moles of, what is that second reactant, S8. Since I do have enough, right? Since I have enough, I have 0.015. Since I do have enough S8 to use up all of the silver, Ag, or silver, right? I have enough of the second to use up the first. What will run out first? Silver will run out first and is the limiting reactant. And then we just continue on with the problem. Continue with the stoichiometry problem to find the answer using the limiting reactant as the starting point. So the second part is really quick. I figured out silver was the limiting reactant. I started this problem with 0.03707 moles of silver, right? The question was asking about the Ag2S. So I will use 16 moles of silver for every 8 moles of Ag2S, and 1 mole of Ag2S will have a molar mass of 247.87 grams. So my final answer here, right, how many grams of silver sulfide can be made, is 4.59 grams of Ag2S, right? That's the ending of that problem, right? If I go back to what this question originally asked us, right, what mass of silver sulfide is produced? So the first thing I did was I figured out how many moles of each reactant I had. Sorry, there's a typo there. Then I figured out how many moles of sulfur would I need to use up all my silver. And then I figured out I would only need to use 0.0023. And since I have 0.015, I can, remember the question we're asking is the reactant 1? Is the silver the limiting reactant? And so we said, yeah, it is. So then I finished the problem by using the limiting reactant, by using silver, and figuring out how many grams of silver sulfide can be produced. And the next few pages are just more practice of these same problems. So we're going to just keep doing them. Each video is just going to be one more problem. So if you want to try number 55 on your own and then check your answer, you can. But these are hard, and so you may have to, watch me do a few more of them before you start trying them on your own.